There are some visual differences between a histogram and between a histogram and a bar graph, but it's the data types that makes a difference between if you use a histogram or a bar graph. So let's draw a histogram of each type. And then later on, when we talk about bar graphs, we'll talk about the main difference. To draw your histogram, what we need to refer to is the classes, including the lower and upper limits, and the frequency associated with those classes. So we have from 1 to 2 to 3 to 4 to 5. Oh, I need a bigger bar graph. Oh, that line's not right. 6, 7. Oh, geez. First world problems. There we go. 8. What magical thing did I do when I drew that x-axis there? Very good. I didn't start my count at 0. Why did I start it at 1? That's where the data starts. Correct. Now, you could technically put it at 0. It wouldn't be too bad for this, but if your data started at 400 and you started at 0, you'd be there for a while. So typically what happens is if you have a jump in the graph, you put like a little, I did that wrong. You put like a little lightning bolt to say, hey, I'm skipping some numbers there. It's a more visual thing. As we're going to talk about later, anytime you're doing stats, you do not want to do anything, on purpose anyways, assuming you're a good person, that gives incorrect, has the viewer read it incorrectly. I'll say it that way. Does this happen in real life? Does it happen during political election years? All the time. These numbers, 1, 2, 3, up to 10, represent what? What does our data represent? The stems, what were the units? So you're talking about yes, number of cattle in millions. Good. The y-axis, going back to the data, notice our largest frequency is 6. So I'm going to count up to 6. What does the y-axis represent? Not the leaves. And so in the terms of the problem, it does represent the frequency, but in the terms of the problem, number of countries. Yep. So you want to say, no, oh gosh. This is blood going to head. Losing childhood memories. Number of countries. So that's going to say the number of countries within each class. And if we had to title this thing, you can say, what? Number of cattle in select European countries. Oh God, European countries. If you want to be even fancier, you would put the year. I forgot what the year was. I think it was 2011. Apparently they stopped counting. Their euro's not doing that well. Well, it's better than the dollar, so that's good. All right, so hopefully you have the data distribution in front of you, 6, 3, 2, 2, 3, 1. But remember, we have some gaps here. So all you're going to do when you draw these rectangles is start at the lower class limit, which is 1 for the first rectangle. Go up to the frequency, go over to the upper class limit, and come on down. That was very descriptive for just doing this. All right, there you go. So I drew that rectangle there because the class between 1 and 1.99 had a frequency of 6. The next class from 2 to 2.99, what was the frequency? 3. The class from 3 to 3.99, what was the frequency? 0. We don't draw a rectangle between this 3 and 4 here. 4 to 4.99, 2. And this is about to suck because my headset's about to die. I might have to start shouting. Edna! No, that's going to... 5 to 5.99, 2, 6, 7 and 8, 0, 9, 1. Hooray. You can shade it in if you want to, I don't care. But visually, make sure you don't make one rectangle wider than the other because then you're giving that rectangle preference. And that's not good. Okay. So what we have on the board right here is a frequency histogram or just a histogram. To make a relative frequency histogram, all you do is you change the y-axis. So instead of saying number of countries, it would be, well, if we had percentages, that'd be one thing. It'd probably be a little bit better with percentages. Percent of countries. And then in our charts, let me go back real quick. We had 6/17, 3/17, yada, yada, yada. Well, those aren't percentages. Those are fractions. So if you wanted to say fraction of countries, that's fine too. But they're typically given as percentages. We'd have to find the corresponding percentage of 6/17. What is 6 divided by 17 in the calculator? 0.352? 35.3%? Well, here's the deal. You would go all the way through, changing all of these to percentages. Unfortunately, 35.3 is not a pretty number. You would probably do 5%, 10%, 15%, all the way up to 35%, actually 40%. But then the bars won't line up correctly with the tick marks. So then what you would do visually to help the viewer understand was you could put the percentages on the tops of the rectangles to say, okay, this is the percentage associated with this rectangle, so on and so forth. It makes it a little better because we don't have a very nice number here. But that's what happens because we only had 17 data values. So the only difference between a frequency histogram and a relative frequency histogram is the labeling of the y-axis, including the title and the values on the y-axis. To do it professionally, I would count by 5%, all the way up to 40%. But as far as the layout of the rectangles, exactly the same. They're not going to shrink or grow at all. Nope. Because if this had 6 out of 17, it's still going to be the highest rectangle. So proportionally, I should say, they should all be the same proportion. These guys aren't going to raise up because their frequency didn't increase or anything. Just the interpretation would be, so instead of saying number of countries, it would be percent of countries. So this would then change to percent. Other than that, the interpretation would be the same. Really, that does say percent, I promise you.